And next, we've got Adam Dorman from Aztec talking about challenges programmable privacy.
Hello. Hello, everyone. Thanks for attending the talk. I'm going to be talking about challenges in programmable privacy with context of the Aztec hybrid ZK rollup that we're building. So first, I'm going to give a bit of an intro to the Aztec hybrid ZK rollup. It's an upcoming decentralized rollup built on Ethereum. It's a hybrid of a public VM model and a private programmable circuit model. So there's the aspect of both public sequencing and private user-owned data that is run locally with client-side proofs and publicly sequenced proofs. And as most rollups, it aims to provide efficiency to Ethereum. It aims to be able to batch transactions, just as any other rollup, while uniquely providing privacy in a mechanism that doesn't sacrifice decentralization. So I guess first off, some reasons we would care about on-chain privacy. There's lots of hesitation with on-chain activity. There's the classic problem of buying a coffee and revealing your entire financial history. And Aztec believes strongly that privacy is an important aspect of any serious decentralized protocol, whether blockchain or beyond. This is the UX that you experience in normal finance. You don't go and buy a coffee and someone sees all of your mortgage details. And in an on-chain world, we should expect the same UX. So there's kind of some problems that lead into each other, and then finally just another emphasis on why even with all these challenges, we think they're worth sticking through and solving on-chain privacy in a practical way. So one of the problems is we're in a blockchain space. The blockchain is a public entity. Everything that we post as data is publicly available for everyone. So how do we have privacy? And this leads directly into the current practical way for having on-chain privacy, which is zero knowledge, at least until fully homomorphic encryption is here. And zero knowledge currently is a very hard space. And in addition to this, decentralization of rollups, while already hard, has unique challenges if you're talking about privacy. You have users doing their own private proofs, you have users owning their state, and you have the concerns that come with users providing first their own prover capability on ideally commodity hardware, and then you have the problem that we are posting these proofs to an L2, and the data involved with practically doing proofs on commodity hardware and posting that data in a decentralized way such that we have a prover network and a sequencer network. So first, I'll talk a bit about the shape of the problem of how do we get to this idea that we want to do zero knowledge proofs, publish them on chain, have everyone do proofs locally. With private data, just in general, say you want your bank to prove your credit, or you want to prove a credit score from a credit score agency, you want to prove certain things such that you can get a mortgage. Generally there is some attestation. There's some idea from a trusted third party that something is true about you without revealing all of your data. And one of the things, if we have this sort of attestation, is how do we use it as minimally as possible? One thing that's very common in our current age is you have a Web 2 sort of service, and they have contractors. They are always balancing security and cost. And there's also vulnerabilities. The vulnerability landscape can be quite scary, and that, again, is a trade-off between security and cost. And what does that mean? That means that if you trust a centralized party to keep your data private, it might leak. And leaks are something we see all the time in the news. Also, that's on off-chain. On-chain, the landscape doesn't really even allow this kind of system. I mean, we want to not just continuously trust third parties. We want to at least minimize that trust as much as possible. This is where zero knowledge proofs come in, and they're quite fit for the blockchain privacy problem because we're able to prove state transitions or relationships on encrypted data with some sort of function, some sort of derived result, like an audit proof or something like a credit score. And we're able to show that, okay, we have a hash data, say that your bank has given a hash of all your financials, encoded in, say, a Merkle tree. Then you're able to take parts of that data, prove that certain parts of that data meet certain properties. Maybe you prove that all of your data doesn't have a certain property. And you're able to keep that data encrypted, post a proof, and prove only that that thing is true. So you would have, say, an attestation from your bank, and then you would prove that you're worthy for a mortgage. You post that on chain. Everyone knows it's true according to the rules. As long as they think that protocol sufficiently determines that you're eligible for a mortgage, they'll give you a mortgage. On blockchain as well, data can always live in encrypted form. So we might not even need that attestation from a trusted party. We might be able to just continually keep our assets in an encrypted form, going from state transition to state transition. And systems like Zcash define assets entirely on this premise. So comparing to Ethereum, Aztec as a hybrid ZK rollup. So what does that mean? It means that we have all of the public functions and states of Ethereum. As well, we have unique, currently to the rollup landscape, programmable private functions and states. So how do these relate? The idea is that all of the use cases, such as swapping, money transfers, lending, on-chain voting of Ethereum apply in Aztec. As well, you have the ability to augment these with inputs that are private in nature. So you're able to, say, have some Sybil resistance, say you have some KYC provider, and you're able to prove that you're in some valid set of KYC clients without showing which one it is. And generally, our philosophy is this is kind of a crypto best practice that right now is hard. It's hard to achieve. Practical privacy has its own problems, but the technical problems still are currently quite sophisticated and hard. Aztec generalizes private state. So what does that mean? It basically, we don't think in terms of assets, we think in terms of information. So we have notes in the system. They are encrypted. You can work just revealing their hash while doing valid state transitions. You can transition to another note without anyone knowing which was the previous note you transitioned from. This uses a system called nullifiers, similar to systems like Zcash. And the Aztec rollup as itself is very use case neutral. It is a communication protocol. It allows, inside the rollup, for users to send each other messages, to programmatically react to that information, and then we rely on something called a portal to actually bridge to the L1 asset world. And obviously, all of the assets already bridged to Ethereum, like USDC, and relying on the Ethereum ecosystem to solve the cold start problem. So this is just a quote from Vitalik. This is sort of motivating that why we are going for a public and private ZK rollup. It's quite complicated to build both. In fact, they're kind of separate. They're separate chains in a way. They have quite a different design. But in Aztec, we want them to be seamless. We want, an Aztec contract exists in a way that's the same contract can interact with public and private states. So you fluently create a contract, and that contract is able to use private data to augment trading, keep things entirely in the private realm. And so why marry private and public? So as Vitalik says, blockchains can make state information global, and stuff like zero-knowledge proofs can make state information private. But to make information private and global, that's something that is quite, on a blockchain anyway, that is not something that one can really do unless, well, basically the problem is, say you have something like a Uniswap pool or you have counterparties, and you want someone to be able to verify, say, that bet went a certain way and liquidate it, or look at the current proof of Uniswap pools. Well, there's no, the only way we can have information private is by tying it to the key holders. ZK proofs allow you to prove essentially that you know something about a hard problem, And what is that hard problem? Well, the hard problem is the relationship between private and public keys. And that is where ZK fits in. Now, stuff like Uniswap pools, that is not just a derivation of key state, that is an active changing state with global players. So we come to this design of augmenting the public use case with private functions and state transitions. This is sort of kind of the same thing. So trusted parties can be used mitigating the amount of privacy leak to just a trusted party in such a system. But for a global system, privacy is something you do need to compromise on. However, you're still able to enact best practices if you have these private states by allowing, say, if you need Sybil resistance, to have that in the private world, or have some private notes that are needed to be consumed by the public side, and we can orchestrate them to create a system with better best practices than the current public systems. All right, so I've kind of motivated why we've chosen to build a hybrid ZK rollup, something that augments public state with private state and proofs. And that leads into how is this practically implemented. Currently, the practical way to implement this is zero-knowledge proofs. So just as Ethereum made it possible for people to make new crypto systems, new applications without thinking about cryptography and consensus, we can do this with privacy. Now, it's a hard problem with privacy. You can't really sequence private state in the same way that Ethereum is sequenced. It's not enough to just have users post the privacy to a sequencer, post their inputs to a sequencer and have the sequencer run the function, because the sequencer would necessarily have to see everything to be able to execute on behalf of the user. That means that the only model that works is for someone to actually run the results locally, show the result of the computation, and then post a ZK proof. So what does the ZK proof do? It's basically a bunch of checkboxes compressed down that you have met all of the constraints needed. Then you prove that your result with a fixed size proof meets all the constraints needed by the system, and then the system is able to trustlessly rely on your result. And even though everything about what you did is private, the rules in the system, the state transitions you are able to make are completely constrained. And thus, someone is able to trust that you actually have, say, some KYC identifier, that you belong to some set of allow list or not in a block list, and without revealing anything more except that the rules of the system were followed. So with zero-knowledge proofs, there's currently, the tooling around ZK proofs is quite active. A lot of it is currently around efficiency for rollups. With Aztec, we want to provide tooling for zero knowledge that preserves privacy, as well as providing the efficiency gains that have come from advancements in ZK. And one of the problems with ZK is it's a very different model. So if you're writing ZK right now, probably the most mature thing you might use is something like CIRCOM if you want privacy. And CIRCOM is a circuit model. It's very different from a traditional programming model. You have to think in terms of arithmetic circuits. You have to think not in terms of if statements, but basically how your system can run all of the circuit in parallel and have the right results. So like something like an if statement would actually become multiplies, like you multiply by 0 such that a certain path doesn't get executed. So all of this is quite different from what users are used to thinking about, or devs are used to thinking about. So to this end, we're developing a Rust-based language called Noir. Noir is a ZK language. There are other languages that focus on zero-knowledge proofs of execution. In fact, there are other languages like Cairo that focus on a Rust-based language that provides a ZK proof. However, Noir is currently the only language that takes this model and has the ability to make privacy on or off chain. So Noir, you're able to make a ZK application compatible with any proving system. It's designed as a compiler stack that's plug and play. You can plug in different backends. It's meant to be future-proof, such that as cryptography advancements, which I'm sure this is a very active field, come out, we're able to easily adapt. And we're not here to reinvent the wheel. Rust is very popular in the crypto space, so we're leaning heavily on its design decisions, not trying to stray too far. But that being said, there are the sort of advantage of the use case, the advantage of building the language ground up, is that things that are difficult, abstractions, basically abstractions that work well with ZK, that are efficient, we're able to build from the ground up. So Noir libraries and Noir language features are focused on what is efficiently provable for a user on their computer in commodity hardware while proving a zero-knowledge properties. And again, that commodity hardware, the users actually executing their own state transitions, is necessary for privacy because we want everyone to be able to use the system, and to be able to use the system, you do not want someone else to be proving your state transitions, or they basically see all of your information. Noir uses an intermediate language called ACIR, so it's abstract circuit intermediate representation. Essentially what that means is that all the if statements, control flow is collapsed down. You have a bunch of arithmetic constraints. You also have some special functions we call black box functions, which are meant for the back end to more efficiently execute on. There's some back-end specific features that intended with the black box functions that they can do more cleverly, while the bread and butter is translating control flow into circuits. And what I mean by circuits, specifically arithmetic circuits, having stuff, again, like if statements basically become clever multiplies and adds, and such that the end result is the same. However, we've collapsed everything down to math. All right, so we're targeting client-side privacy. We're targeting tools for zero knowledge. As well, we're building a roll-up. And currently, the roll-up decentralization space is largely focused on training wheels. The roadmap to roll-ups is seen as progressive. We want to launch decentralized from day one. Users do their own knowledge proofs. There's a prover network. There's a sequencer network. Sequencers are decentralized. Anyone can be a sequencer. Sequencers have hardware necessities that are similar to Ethereum as a goal, while the prover network, out of necessity, is a little beefier, that the prover network needs to actually do heavier computation. So one thing the prover network does is, with the private proofs, for them to be doable on commodity hardware, they're a little bit bigger, and then Ethereum call data or Ethereum blob data, it comes at a premium. It's quite expensive. So one thing that the prover network does is actually kind of combine proving systems such that we take the user proof, which is able to, on commodity hardware, anonymize them, and we overlay it with more in-depth proving systems which produce the smallest amount of payload, and that is what gets on Ethereum. So there's a lot of challenges that we're currently working on. We have requests for proposals. If any of this interests you, everything's public. Our GitHub's public. We're actually gearing up for a sandbox launch. And all of these problems are stuff we're engaging with the community, because this is very important to us, but it is also quite hard. You have to have a system where there's not just one prover. It's not just, we need provers to be kind of beefy, but we don't want them to just be, in practice, one winner-takes-all system that can, in practice, take down the system. So this is active work. I'm not going to go into the proposals here. However, there's a few different ideas we have. They're all published online. We're hoping to finish this up by end of September. All right, so I've kind of talked about what challenges you would face if you're trying to make a programmable decentralized rollup. So I'll just circle back to why are we interested in privacy? So with all these challenges, we emphatically think that privacy is worthwhile. There's things that we believe that privacy is a best practice. While there's practical problems with on-chain privacy, the idea that originally when Bitcoin came out, for example, it was seen as an anonymous system. over time, that kind of proved to be security through obscurity, and now old blockchain data is increasingly becoming de-anonymized. This is quite dangerous. There are privacy concerns with financial applications, but a lot of non-financial applications have no reason to be public. And privacy provides things, best practices like abilities to do MEV resistance. You might have a swap platform that actually requires you to privately signal your trades such that someone can't just front run you because you've actually, in the private world, shown that there actually is sort of a block delay, and they don't see that you're signaling that you want to trade, and they can't front run you. Censorship resistance, purely because all of the private proofs just look the same. They're just some ZK proof, and they validate some state transition, but their details are largely hidden. In fact, stuff like the whole contract logic could be hidden just using the contract hash. Doxing resistance is probably the most obvious. In a traditional blockchain, there's always the risk that your entire on-chain history is linked. And there's kind of more interesting things you can do in such a setup, like a traditional, if we talk about the private blockchain initiatives, and private in the sense of corporations just working with people with allow lists, then there's the ability to build such a system on top of a private rollup, only working with parties that you trust, and not even revealing the contract logic while using such a system to make sure that everyone's honest and that all of your system is working as expected. So to reiterate, to this end, we're developing Noir to be a general tool for programmable privacy. So Noir is not just blockchain. Noir is not at all just Aztec. We have cryptography backends that we're developing and also other ones that we're integrating with. And then Aztec itself is aiming to just be a general purpose framework for private transactions. Currently, so privacy is a holistic problem. There's many concerns that come with privacy. However, right now, one of the blockers in solving these concerns is that it's very technologically challenging. So at Aztec, we aim to provide a platform such that application developers can focus on application-specific concerns and making ZK a lot more tractable for the average developer. And if you're interested, reach out. Like I said, we have requests for proposals. If you're very interested, we are hiring. And yeah, I hope to hear from you. And I guess we can start with some questions because I have about 7 minutes. Okay. Yep.
So you're mentioning you guys are leading this decentralized prover now, right now. So, and you also mentioned you don't want this to be winner takes all situation. So ideally, how are you imagining this to be orchestrated?
Right. So this is getting into the prover network problem is hard, and there's people more working on the sequencer proposals in depth than me. But the essential idea is that it's okay if sequencers are reliably getting proofs from a small amount of users, but it's not okay if the ecosystem is such that smaller provers basically can't enter, that like the moment the big prover leaves, that there's just nobody. So we're taking ideas. Definitely, if you're interested in this, I encourage you to read the sequencer proposals. But the idea is to be able to split up the work, to be able to have people actually get the work that are not just the strongest prover. So we might particularly emphasize this. We might give rewards to provers that actually don't end up making it into the network, such that they're around for liveness. But generally, the idea is it's a hard problem because you need a strong prover network that has good hardware. The main thing we want to mitigate is the idea that someone who's providing a lot of hardware suddenly goes away. There's not much that someone providing like winner-takes-all situation can do to harm the network, except, well, just if they're gone, then, or are there any other provers to take their place?
Can you give me some examples when private states are useful? Like, for example, DeFi applications where you need public-facing outputs, where that could leak a lot of your private states. So when your anonymity set, when your private states are actually useful and what people can build.
Right. So oh yeah. Sorry. Yeah. So the question is, when are private states actually useful in DeFi? I guess that was the question. Yeah. So private states. The idea with private states is that there's a lot of information you want to take on chain that may leak more about your identity. You might have on-chain compliance. You may just be trying to use a platform being docs resistant. You might have stuff like protocols that are entirely peer-to-peer, and those can be entirely private if there's just people sending messages to each other. But the main idea, I think, for me, is that privacy is sort of a best practice. You want to be able to post more information on chain. You want to be able to post, say, that you exist in a KYC set without actually saying that you're a specific person in that KYC set. Those sort of things, just being able to prove that's, I guess the idea for me is you want to do more on chain, and whether that's just normal transactions and not get doxed, or you want to bring more information on chain to have more trust in the system, but you don't want to reveal everything about that information. You're able to prove the provenance, you're able to say, this person is vouching for me, I exist in this set, but I'm not telling you which person in that set I am. Yep.
So do you envision this to extend to machine learning training and inference? Like, because that's a big problem with machine learning, like the fact that if I train on my data, I'm giving you out, and homomorphic efficient is not there yet. So is this something that is as ambitious as to eventually getting there?
Okay, so the question, as I understand it, is do I see this applying to machine learning and the inference part, not the training part, right? The training. Machine learning training. So with machine learning training, I think it's definitely, so with all of the algorithms in machine learning, they're definitely amenable to being arithmetized. I mean, it's pretty similar at a high level view of machine learning. I think training is probably the biggest bottleneck though. So commodity hardware is able to do ML inference, actually run the models, but training is kind of still the cutting edge. Like if we're talking about things like ChatGPT, it's just the latest chips, very expensive computers. And it is certainly algorithmically possible, but I think the more practical thing short term is to just run models and have like the ZKML idea. Yeah. Yep.
Can someone build a mixer on top of your technology? Like, do you guys do KYC? What if they?
So yeah, that's I think there's a very important distinction we draw that we're technology neutral, that our rollup is just an information platform. We do not interact with, there's no native assets in the rollup. The rollup is purely, you're able to send messages and you're able to then build L1 contracts that interact with that. So the basic answer is yes, that someone could. Now that is kind of where practical privacy comes in. So with practical privacy, we have things like compliance. With application-specific platforms, the developers do need to take into these kind of concerns. This is something that we aim to just solve the technical aspect of, but there's a lot of practical concerns with building those kind of applications for sure, like KYC. And that's why I do talk about having KYC, but just proving you're part of the KYC set without revealing, say, a KYC ID. Yep.
Yeah, I have two questions. Does the code for private state and the code for public state get compiled out the same way? And if that is so, then how can Aztec tell the difference between the two states and execute accordingly?
Right. So is the public state and private state compiled down the same way? And the answer is no, not really. We take actually different models. So we have the same Noir programming language, the same Noir Aztec contract language that lives on top of Noir, but private states are compiled down to circuits that users run on their machine, while public states are actually, it's kind of like two blockchains glued together. So there's a message bus, and there's quite a separation with them, but we try to abstract that, A, by having Noir on one Noir contract able to be compiled down to both public and private, and B, by having these be sequenced by the same sequencer, such that we can make the nicest possible transitions between private and public, such that for example, if you kick off a public function from a private one, that it runs in the same rollup. And yeah, there's definitely different concerns, and they're quite separate, so there's no possibility of those being mixed up. All right. I think that's all in the time. Thanks very much, and thanks for your questions.